Hello friends, welcome back. Hearty welcome to you. In this session, let's have a look at another example where we are evaluating left hand and right hand limits. So we have been given a function. We have been asked to find out whether the limit exists at a equal to 3. So let's go ahead and plot the function. Also have a look at the function and try to prove it. That whether verify whether the limit exists or not. Okay. So the function is given by the interval -1 less than x less than or equal to 3. Function is x plus 2. If the x is between 3 and 5, then the function is given by x square. So let's just try to plot this. X square when between 3 and 5. So can I say if it is 3, oh my god, it should be 9 somewhere else, correct? Okay. Let us see. Okay. First what we will do, we will plot this one between -1 and 3. So I will take 0. If x equal to 0, I will write it down here. I'll write it down maybe somewhere here. Okay. Y equal to x plus 2. X 0, y 2, x 3, y is 5. So that should be enough for me because it's a straight line, but I'll go for another one. X equal to 2, y equal to 4. Similarly 1, it is 3. So that's enough. So let's go ahead and try to plot this. If x equal to 0, y equal to 2. If x equal to 1, y equal to 3. If x equal to 2, y equal to 4. If x equal to 3, y equal to 5. So this is how for between -1. So I have something more. If x equal to -1, then -1 plus 2. So it should be 1. Right. So you can see the straight line very clearly. This is how it looks like. Let us say we are trying to make it pass through all of them. That's a straight line. Okay, so this is the straight line we have. Right. Now let's go here. If it is 3, it is 9. Okay, so somewhere there, let us say somewhere there. And if it is 4, it is 16. So it's something like it's going on. Okay, what I will do now, I don't know where exactly the 16 will come, but I know you can actually see how this curve looks like, right? Y equal to x square. Y equal to x square, how it goes? It goes like that. So somewhere here you have the value, so it will go on in that direction. Okay, now we are interested in x equal to 3. Now can you see that there is a break in the plot? Because if I am coming from left hand direction with f of x, if x towards x equal to 3, my function is approaching the value of 5. Whereas from the right hand direction, if I try to come from 5, 4, 3, I am approaching a value 9. So the limit will not exist there. We will also prove it by formula. So we will take both left hand limit and right hand limit. Let's go ahead and do that. Here we go. So first I will say LHL, then we'll have RHL, right hand limit. Here x equal to a minus h. Here x equal to a plus h. I think by this time you are very clear with the concept why we are going with a minus h and a plus h. Again h tends to 0. That's the whole idea. You want to make it minimal. Okay. Now if it is less than 3, I have to use my function f of x equal to x plus 2. This is nothing but equal to x plus 2 whenever x tends to 3 minus. Similarly, f of x equal to x square whenever x is 3 plus. So if I substitute x equal to a minus h and a plus h, what I will have? I will get, this is, I have to prove limit, so I will say limit. I have to prove that. So that's nothing but we are saying limit. Okay, I don't want to confuse you with that. Either you can take f of x or you can take x plus 2, because limit of x plus 2 as x moves towards 3, and this is nothing but limit of x square. I can write here f of x equal to x plus 2 in this case, and f of x equal to x square in this case. Left hand limit and right hand limit. Okay, right. Now when I go here, instead of x I have to, now that's nothing but equal to limit of h tends to 0, f of a plus h, that is nothing but a is how much? A is nothing but 3. We said a equal to 3, so that is nothing but 3 minus h, 3 minus h plus 2, that is equal to limit of h tends to 0, 5 minus h becomes 0, then the value will be 5. You can see that that is what we have got when it is 3. So same thing, whether you graph them or you do them, you will get the same value. Now this is nothing but equal to on the right hand side. Remember, if it is left hand side, your x is a minus h, because you are approaching from the left hand side. So you are going from a value which is less than a and you are moving towards a, whereas here you are coming from a value which is more than a and you are coming down to a. So that is the difference between them. Now this is nothing but equal to limit of x is nothing but here a plus h. So can I say a is 3? Can I say 3 plus h whole square as h tends to 0? Because we know in this case x equal to a plus h, I have to put. So f of x is nothing but equal to f of a plus h. Here it is nothing but equal to f of a minus h. Now this is nothing but equal to 3 plus h. H is 0. I can actually expand that to, I can say limit of h tends to 0, h square plus 6h plus 9, that's nothing but equal to 9, because h 0 0, you are left with 9. So you can see left hand limit is 5 and right hand limit is 9, both are not equal to each other, so the limit will not exist at that particular point, at the point x equal to 3. So that's the two examples about left hand and right hand limit. One where we have seen there is continuity. Now you understood the limit, how we can say the limit exists or not. Whenever there is a break in the plot, that means the limit will not exist at that particular point. So the curve can change. You can have one straight line, then you can have curve, then you can have straight line. But as long as they are continuous, that means you don't have to then you don't have to lift your, let us say something like when you are drawing this, you don't have to lift your pen. You can do it without doing that. Then you have a limit, and if the value exists, so it becomes also continuous. We will see that in coming sessions. In the next session we will look into evaluating limits by using factorization, where we have 0 by 0 form. We have to factorize to find out the limit.